Hello guys and welcome back to the sim. Now I've had to put the pedestal on hold while I wait for the Arduino shields to come through so I can connect all the wires in the next part of the project. In the meantime, people have asked me, do I have any plans to convert a Saitek throttle unit? Well, I didn't, and as I've already got my throttle unit fitted in the sim behind me, I've gone up this weekend and created the plans on Fusion. If we take a look, I'll show you what we're about to do. So in front of me, I've quickly drawn up the Saitek throttle unit on Fusion. The first thing I want to create is the speed lever. So I've drawn this up and that goes on the left hand side there. After that we'll create the throttle levers. Now these throttle levers are fully operational, all the buttons will work. If I take the cover off here, there we go. I've got the decal still showing. Let's find where that is. Let's turn the decal off. There we go. So you can see that we've got the thrust reverser arm here. It's got a detent spring and ball bearing which holds it in the correct positions. We've got our two buttons. We've got a cable channel way through the handle here. Another cable channel way for the main body. And as for the lower body as well. And finally we've got a fixing screw at the front. So if I put those back together, there we go. And the last part we're going to create is the flap lever. Now because you've only got 3 levers on a Saitek body, we need to create the whole assembly. And because it's quite a small assembly to start with, even the smallest 3D printers can cope with this. And there we have it. So if I zoom in, we've got the gated flap control assembly. We've got the horn cutout that I've managed to get in. And that is pretty much it. If I get rid of everything else, let's remove the end body. You'll see the general build-up of this. So there's the end plate removed. And all we've got inside is a high quality potentiometer, 10 kilo ohm, affixed to this plate here, or this bracket. That just slides in onto the flat handle, and inside here is a spring that holds the whole assembly together. It should become a lot more apparent when these are all printed out and we'll head out to the workshop to build it. The electronic components required for this build are quite small. First of all, we need a Leo Bodner joystick card, a big black push button for the horn cutout, 2 cheap 10k ohm potentiometers, 4 black push buttons. Now I'm using a high quality 10k pot for the flap lever. We need 2 rotary switches. These cheap ones are ideal because they've been designed around. All we need out of them is the spring inside and the little ball bearing, as you can see. And that is for the detent of the thrust lever. I'll put all the components on the website so you can easily download them and find out which parts you need to build. Now even all these parts are designed for this Saitek Throttle Quadrant. They are actual real size, real dimensions, and this means I can use them by importing them into another design when I come to create the real throttle body for the 737. And hopefully you can see that they're just going to slide on like that. And then I can use those in different versions of the throttle quadrant as we go along. First part of the build, and that's to put the handle onto the lever. Well, that was a very satisfying click. And then just put the screws in. So all we've got to do is put the handle onto the left hand stick, push it down, and it's done. Before we can move on and build the first throttle handles, we need to take apart our rotary switch and get the ball bearing and spring out of it. And all I'm going to do is cut the 4 tangs off on the sides. You can see that this one has already been used. The reason I use these is because these are a standard fit and everybody will have them. And if you just carefully, I felt the ball bearing go there, there it is. Now there are 2 ball bearings, but we only need 1, and the little spring. I'm just going to pull the spring out. I'm going to measure the diameter of the spring, and it should be about 3 millimeters, I think. Oh, it is. There we go. So the spring is about 3 millimeters. And I've got this drill bit here, just slightly bigger, at about 3.2 millimeters. What we're going to do is we're going to prep the handle ready for the spring. Now, if your 3D printer like mine has a bit of a rough finish, then all we do is we insert the drill bit into the spring hole. And hopefully the spring will fit in there lovely. And it does. I'll remove the spring for the time being. There we go. First up, I'm going to use the potentiometer. This is a 10 kilo ohm. And that is just going to push into the back piece like that. Flip it over. Grab the nut. And screw it together. We've got our pot in position. Now it's time to fit our spring and ball bearing. Now this may be a little bit fiddly. Oh, and it's gone in. Time to fit our thrust reverser handle. That just pushes on like that. You can see the operation. And then we've got these tiny little triangle pieces, and these are the spring plugs. And they're designed for the ramp to go against the spring. Push in. Oh. That's the plug fitted. So that's it at off, idle, detent 2 and full power. To finish our main body off, we need to now install the push button. That goes in that hole there. And just need to put the nut on. We can put the throttle body to one side now, and we'll concentrate on the handle knob, the push button that goes in that, and the wiring. I'm just going to pre-tin both the wires and the switch itself. On goes some heat shrink just to protect it, stop it from shorting out. Now I've got to try and get these cables through this handle, and there is a dedicated hole for that. In they go, and out they come there. And now we get to see if it fits or not. So that should now firmly push into the housing, like so. Before we can build the back plate on the handle, we now need to connect the rest of the wires. Now it's time to install the back plate, and that hopefully just pushes on there. It's a nice snug fit on the pot, and we'll get some screws in. There we go. It's looking quite good. Now all I've got to do is to cut back on the wires. I'm going to daisy chain the grounds inside the unit, so we only need one ground for the 3 devices. And that's what our throttle body is going to look like. From the back, the top, and especially where the cables are hidden inside the channel there, and you can see how perfect that fits into the handle. Then we've got our thrust reverser that now locks into certain positions. Feels great. And that just leaves one hole at the front, and that's to mount a mounting screw so we can locate it onto the Saitek unit, which we shall do now. Now we're ready to put the second one on. That's the speed brake, the throttle lever is complete, and that's all we can do to this part of the Saitek unit. We now need to create the flaps lever and the flaps box that will attach to the side of the Saitek unit here. So for the time being, I'm going to move this out of the way. So first up, we're going to install a high quality pot into the bracket assembly. I'm going to put the bracket assembly to one side for a second, and here is the flaps lever body. We've got our black push button, and that's just going to mount in the hole. Next we need our flaps lever. To build our flaps lever, we take the stem and we need to put a screw into the base so we can attach it to the potentiometer. Now we need to put a spring into the upper flaps lever assembly, and before we do that, I highly recommend, I've got a bit of cotton thread here. I'm just going to thread it through one loop of the spring. Yep, there we go. So we've got that attached to one end of the spring, and locate it into that hole, and the screw needs to attach it at the upper end. So now we need to thread this bit of cotton thread through the hole in the base lever stem. We're going to feed the base into the upper part. That's our flap lever sprung loaded, ready to be inserted into the base. And hopefully you can see the hole here, and that is to tighten the flap lever onto the shaft. Like so. Next we've got our detent, and all we're going to do is put it on like so. And again, I'll put it on backwards. And attach that with a few screws. Now, as you just saw there, if you use a bit of sandpaper and you gently smooth out the ridges in the raised text, you won't get that bleed from the permanent marker when you use it. And as you can see, that's come out crystal clear this time. The flap handle. That feels really good. I'm going to put the last touch on, and that's the decal. Now I'm just going to use a bit of super glue for that. With our flap lever box complete, I'm going to use some double-sided foam tape to mount the two sections together, a bit like that. Off goes the soldering iron. There's our unit complete. There's our Leo Bodner card all wired up very quickly actually. And let's go and give it a go. Here we are back inside. I've plugged the USB into the computer. I've got the game controller card set up. Let's have a look on the computer and see what works and what doesn't work. So if we click properties, there we go, we can see all our channels. So we'll start with the buttons first. Number 7 for that one, number 9 for that one, number 8 for that one, number 10 for that one, and finally the horn cutout, button 11. That all works spot on. For the axes, number 1 thrust reverser, there you go. You can see the x-axis moving, the y-axis is moving, and finally got the flaps lever here, and that's the z-axis. Okay, let's open ProSim up and see what ProSim thinks of this. ProSim server is up and running behind me here, and in the config under drivers you need to make sure that the direct import support for joysticks is ticked or enabled, which is right there. Into the configuration, into the combine config, throttle MCP, down to lever, and the first one should be the flaps lever. I'm going to select the Leo Bodner. It is the Z-axis, it's already picked it for me. There we go. So let's do flaps up first, which is there, and all I'm going to do is hit setup. Done. Move it to position 1, push set 1, set 2, 5, 10, 15, 25, 30, and 40. That's all that's required in ProSim. That's how simple it is to add additional axes. Now to check that it's working properly, we scroll down to the flap input on the MCP page, the throttle MCP page, and we simply move it. And we look at this value here. If I can highlight it, yes I can. And that should change now with the corresponding flap position. That is it. We have one fully working flaps lever. Let's do the thrust reversers now. So it's back into config, configuration, combine config, back to throttle MCP, levers again, I believe. I'm going to scroll down and find throttle left, not that. Throttle reverser left. Okay. Open the box, select the Leo Bodner. It's definitely not the Z-axis. And this is the left, which is number 1, so it's going to be the X-axis, I believe. So we can find out when we move the lever. Yes, it is. It's in reverse, so I've got to change it round. X-axis reverse, that's more like it. So I'm going to set them in, which is the position it's in now. And then I'm going to move it all the way to the max, which is actually holding it up. There we go. There's detent 2, detent 1, and off. While I'm here, I might as well do throttle lever 2. There we go. It's going to be Leah Bodner again. It's going to be the y-axis. I'm going to go straight for reverse. Let's have a quick look. Yes, it is. Good. So I'll set min, and then I'll hold it up into max. Hit OK. Once again, we go back to the config page, and we should be able to see what it's reading. So both the reversers, as you can see, are down at minimum. Number 1, max, detent 2, detent 1, and off. Detent 1, detent 2, and max. That is working really well. Big smile on my face. And now, just looking for if they're similar down the range. Pretty close. That's all the axes mapped out. Now I'll show you how to do one button out of the 5 that we've got connected. I'm not actually going to go ahead and do any more than that because I'm not actually going to use this unit. This is just for prototyping and for those guys that have got a Saitek base unit that would like to make a 737 quadrant look-alike basically. But just to show you a quick button, we'll do the horn cutout. If we go into ProSim config, combine config again, back down to the throttle MCP, into switch, and scroll down to the horn cutout switch, which is the big black one here. There it is. I'm going to set the Leah Bodner, and I'm going to push it, and it tells me at the top here that it's button 11, and I need to select button 11 in the list. Hit OK, and then find it in the list again. Here we've got the gear horn cutout, and if I push it, it will show pushed on the display, and we are done. That'll do for this episode because that's as far as I wanted to get. That's all the units working, and you've got enough controls there to get you started. I may create a little box on the side here for the parking brake to go on this side, and perhaps on the bottom the start levers. Moving on from this Saitek unit, I might create my own base unit here. It looks a bit more realistic because the Leah Bodner can take up to 8 inputs, which means we could use the 3 pots from here and create our own unit. Very simple, no different to creating the flaps unit here. So that will give us the start levers and the parking brake perhaps in the next episode. And then from that, we can go on to making it motorized and even more real life. The only problem is when you 3D print these parts, when we go to full size, that is a lot of printing time and a lot of prototyping. Excuse me, that's a lot of prototyping when you get it wrong and it doesn't quite work. And one little change requires a drastic reprint. It's something I don't look forward to. But we'll get there, guys. For now, take care, sim out.